to a home like this, the conditioning system is very tiny compared to the size of a conditioning system for a conventional house, but the system has to be much more flexible because the variations in moisture loading and in sensible or temperature loading can vary all over the map. If you have nobody here and you're just sitting in a chair reading a book, then temperature is typically going to dominate. But then when you have a party, you're cooking, you're exercising, you're showering, then the moisture will dominate. And so you really need to have a system that can have much more variability in how it handles moisture loads relative to the temperature loads or thermal loads.
And that's partly because the envelope is tight, and I think you were saying before that the existing systems are dependent on leaky houses.
They're really designed based on a leaky house that's more climate dominated rather than internal load dominated. If you perfectly insulated and sealed this structure, it would really be just like being in a spacecraft. And in a spacecraft, everything is geared toward getting rid of heat and getting rid of moisture.
Right.
And so, everything we do, we're heaters and humidifiers, and all of our activities heat and humidify the house. So whether you're exercising or just simply breathing or cooking or taking a shower, you're generating moisture, and then using the stereo, watching TV, again cooking or exercising your metabolism, you're giving off heat. And so a perfectly insulated house always has to dehumidify and always has to get rid of heat. And then with not so perfectly insulated, but still highly insulated and sealed structures, now you're in a range where you've got this mix that you need to be able to handle as they occur. And that's where the intelligence and the flexibility of the system is so important. So it's a tiny system, but it has to be able to move around in a very nimble manner. And then this area here is our CERV system. And it's got the wires around it are different temperature sensors and things that...
This is the product.
Yeah, so this box down here, all these wires are just temperature sensors and things that we're monitoring. And so the CERV, so that's a data acquisition system there. It's just scanning and taking temperatures. And then the box down below is in effect a heat pump system. It's a sealed system so that everything's in the box. There's not an inside unit and an outside unit like a regular air conditioner or heat pump.
Right.
These are ultra quiet components, and the industry that the compressor comes from is more from the appliance side rather than the air conditioning side of the industry. And that's because they build a more appropriate capacity for conditioning this type of house. Smaller, and then they're also much quieter. Compressors designed for things like refrigerators and other things like that must be much quieter just for a consumer preference.
Sure.
And that allows us to bring this inside and to not have a large adverse sound impact on the house. This is a modular system so that we'll actually have two of these, but we just wanted to put a single unit in. We redesigned the housing and some of the internal structure, and so we have a couple more units we're going to put in. But the idea is that you build up to the size system you need, and so we think a 2,000 square foot house would use two of these CERV units, two of these conditioning units. This is really the brains of the system. That's it's set up with dampers that shift airflow so that when we want outside air to be cooled or we want it to be heated, depending on the time of year, it makes that decision and then moves the air either to the heating coils or the cooling coils. And then it also is what determines whether or not we're using fresh air or recirculated air. So once we've done enough fresh air supply to the house, but if we see that there's some additional conditioning, that's needed in the house. Then we can recirculate air as needed. And then we collect, this is defrost water. So even though there's not a lot of water in the air outside, the coils will still frost up, you know, as they do with typical heat pumps.
But it much less
Right.
than
Right.
we normally see.
And there's useful energy coming out of that, but we're measuring that, so we keep track of that. And another novel feature of this is that when it goes into defrost mode, rather than being a dissipative type of activity,
Yes.
putting heaters on or hot gas defrost, we can defrost this in a manner that gives us energy recovery. So it still has a beneficial energy impact on the system.
That then cycles back into the system itself? Or?
Right. Yeah. Yeah. And here, this shows right now we're supplying 100-degree air into the house, and the temperature from inside the house is about 66 degrees. And looks like the outside is maybe about 35 right now, and then we're sending about 24-degree air outside. So we're cooling the outside air down to about down 10 degrees, and then bringing elevating the temperature about 35 degrees.
Is there anything here that shows how much energy you're using?
Yeah, that's actually right here, 500 watts, which is a tiny amount.
Compared to what a house like this normally would have in a
maybe
in a day like
10,000
today
watts.
that's near freezing.
Yeah.
Maybe 10,000 watts?
Yeah. Yeah. And that'd be about 30,000 BTUs per hour.
Wow. Pretty cool. Now, what do you call this unit again?
The CERV. The Conditioning Energy Recovery Ventilator.
Right, it's right there, right in front of me.
And the idea is that it's here to serve you.
Great.
So, we've monitored and analyzed so many homes, from the mid-'70s when I was looking at solar heated homes. And you go into them, and it was like walking into a submarine, an equipment room in a submarine. It was just an ungodly mass of electronics and piping and that. And so we wanted this to, really make living simple in the house. And so we've been trying to achieve that.